Okay, number 4. So I did the start, so I'll just do it again quickly. Okay, what's the EMF? Yeah. Actually, why don't I write down the exact definition here? So, EMF of a power supply is the energy converted into electrical. I'm writing too much. Is the energy converted to do work when a unit charge is passed through. And then if you want to write that out as a formula, in other words, 1 volt of EMF converts 1 coulomb into 1 joule. So if the voltage is 1, it means when a coulomb is passed through, it gives you a joule of work. Okay. This question was 2 marks. The key thing I'm really looking for is for you to recognize that EMF tells you how much work you are dealing with when you have your charge passing through. Okay. So really, the bigger the EMF, the more work you can do with your 1 coulomb. Yeah? Okay. B now. Oh yeah, we said this last time as well. So what is the requirement of the resistance in the voltmeter? Yeah. Big. And then in the ammeter? Small. Okay. Now, C. In the circuit above, when X is open and the voltmeter reads 8.3, when the switch is closed, the voltmeter falls to 7.58 and the current is 3. What is the EMF of the power supply? Now, we were talking about this the last time. And Bilal had the idea here. He said this is 1 mark, so the answer must be in the question. And what is it that we decided it was? And you would be correct. Yes, congratulations. You will get at least 1 mark in the exam. So the EMF is 8.3 volts. Right, now the next one is what's the resistance? So what law do we need here?
V equals I.
This is, yeah, what's it called?
Ohms.
Yeah, V equals I or. Now, what do we have? We have the I, don't we? So we have R equals V over I, which equals, what's the I? It's 3. No, the I. Yeah. Good, okay. Now what's the voltage?
8.3.
Now you see we have 2 different answers, and I'm sorry to say they're both wrong.
What?
Well, no, it's now the reason is, if you look at this, what's the voltage of this battery? 8.3. And what's the voltage in the voltmeter?
7.7.
What is it?
7.58.
Yeah. Now, I am very sorry if I told you this the last time, if it was the wrong way around. You have to look closely at the diagram here. I'll draw it here very quickly for you. It's one of these stupid things to try and just catch you out. There's your voltmeter. There's your resistance. There's your ammeter. Okay. If you look at the voltmeter, it's connected here to here, yeah?
Yeah.
Now, which way? Oh wait, maybe they have the diagram the wrong way. No, sorry. I was looking at the next part. I apologise. Who said, what did you say was the voltage?
8.3.
And what did you say? Okay, you're the one that's right here. 7.58. Because, yeah, the question said when the switch is closed, the voltmeter 7.58. So yeah, it's 7.58. So sorry, I'm confusing you. What is this, please, if you calculate it? 2.53 will do fine, thank you. Okay, now the next part is calculate the internal resistance of the power supply. Now, I suppose there's a formula if you want to use the formula. So will we just use the formula? The formula in the book is, if you look at the formula book, EMF equals I times R plus R. Can you see that in the book? It's on page 3. It is 1, 2, 3, 4, about the 7th formula. No. It's like, yeah, it's like that formula. In fact, this formula is not in the book. Okay, so I think it's important that you write this formula down beside that one in your note, in your formula book, so you remember that you should learn this one. So, not in book. Must remember. Okay, what's the EMF for this question, we said?
The EMF is 8.3.
8.3, yeah. What's the I? 3. What's the R? 2.53, and then the small r is the resistance inside the battery. So after some rearranging, we get the small r is 0.24 ohms. Okay. The next one. Hey, come on, focus here. What's wrong? What's wrong, Bilal?
You said after a little rearranging, like.
Yeah, just it is a little rearranging. The next he wants is the power. 1, 2, 3, 4, 5. The fifth formula, number 5. The fifth formula is the power. Power equals I squared or what's the I?
3.
So squared.
9.
And the or he wants the power in the big resistor.
2.53.
Is it 2.53 for the big resistor?
Yes.
Okay, so what is that?
22.77.
What is it?
22.77.
Yep.
You can
Yep.
calculate it by using IV.
Power.
Give me 22.59.
Yeah, that will do too. Though I think the only difference you're slightly off is because rounded. You know, you got
59.
Yeah, you can use that formula as well.
When switch X is closed, so we use the 7.8 V. The voltage is 7.85.
Yeah. Oh, did you use 8.5?
No, I use 7.
You get, I got
Yes, you should use.
What's in 2.7?
Yeah, 22.74.
0.74.
Oh, 7.4. Sorry.
Is same thing.
The same thing with the V.
Yeah.
What do you mean?
IV, I got 22.74.
Good. Okay. Good.
You're on radio.
That doesn't matter. It should be the same. He's not using sine or cos, so it's okay. Right. What's the last one? The formula for charge?
Q equals I.
Q equals IT, and it's 2 minutes And what's the I?
3.
3, isn't it? So it's 360 coulombs. Okay. Now, the next one. These muffins are so cheap. They like fall apart. Okay. Huh? What'd you say? Right. By the way, the reason I got confused earlier was, for a moment I was worried that the voltage was looking at the top instead of the bottom. Which way does the current flow?
From the voltage.
Yeah, so this one's first and then this one's second. So you'll get the voltage here. For a moment I was panicking. I was thinking that the voltage was going the other way or something. No need to panic. Okay, it was fine. Take it easy. Right. Next one now. So last part D. Okay. Firstly, he says use Kirchhoff's laws, or in other words, your understanding of current, to find I1, I2, and then EMF. So let me draw this here. Okay. Power supply, and then this one here, this one here. This is a 5. Then you have a little battery or capacitor or something. And then here it's a 3. And then here is a 2. And then this is a 9.25 volt battery with an internal resistance of 0.42 ohms. Okay, positive, negative. Right. Oh, sorry, and you know the current here. So there's like a little ammeter here. Right, the first law, or the first idea to use is that, he calls this one here I1, and then here is I2. The current that goes in here must equal both of them, yeah. So your first formula is I1 plus I2 equals, which is I total, which is 2.6. 2 marks for that, okay? Well, hang on, I'm in the middle of it. So we have to find I1 and I2. So naturally enough, we need another equation with I1 and I2 in it, okay? That's the one with the current. The current that goes in must equal the current that comes out. And then the second idea we use is something to do with the voltage. What is the total voltage for this? 9.25. Okay, so your 9.25, that has to equal the voltage here. Now, do you know the voltage here? You don't. What do you know? Resistance. What's the resistance? 5. And what's the current? No, it's I1
minus.
Yeah, well, no, yeah, you could do 2.6 minus, but make it easy, it's just I1. Now, what does Ohm's law say?
V equals IR.
V equals IR. So what's the voltage in this resistor?
I1.
It'd be 5 I1, because it's V equals IR.
And the V is 9.25.
That's the total. And we're looking at the voltage at each part.
Which is 1.85. 1.85.
What's 1.85?
I1.
Oh, no. Well, I'm not finished. This isn't the end of the formula. Yeah, you're jumping too far ahead. So now continue. Next piece, okay? Now, let's look at this resistor. This resistor here? Resistor. What's the resistance? 2. What's the current here? 2.6, very good. So what's the voltage? So again, this is 2, and this is 2.6. So what's the voltage? It's 2 times 2.6, which is 5.2. Okay. And then lastly, here there's a little resistor in the battery. So a little voltage will be used up in the battery. Again, what's the formula? V equals IR. What's the I? 2.6. And what's the R?
0.42.
0.42. So if you multiply them, please. What is it? 1.1. Okay, can you just add these together, please? Or can you? Yeah, this can give me the I1, can't it? Yeah, what's the I1 here? I1 equals 0.592 amps. Okay, and can you tell me then what the I2 equals? What is it? 2 exactly. 2.01 I got here. Yeah. Now look, I hope somebody is thinking, hey man, what about this guy? Right?
That's I2.
Yeah, but I mean, here what did I say? The total current out here must equal 2.6. And then I was looking at the total voltage, yeah? But I don't really care so much about this one because when you have, it's the same. It's the same. So this voltage will match up with this voltage. Okay? You might not be satisfied with this, but if it helps, if you want to look up your notes or look online, this is actually called the first law, and this one here is what's called the second law. So you see this one does with the current, and then this one here is with the voltage. And all I'm really saying, if you think about it, is this 9.25 volts, yes? It must get used up all the way around the circuit, okay? So some gets used up here. Sorry. Some gets used up here. Some gets used up in the battery. And then some gets used up here. But, yeah. Oh, you just substitute this into this one. Okay.
What if we calculate the total resistance inside the...
And put them together.
Yeah.
Yeah, but that might make it more difficult because the problem then is you'll get I1 and I2 together. You know what I mean? And actually, no, you can't really because the current is different in each resistor. You know what I'm saying?
Yeah, but most of the current will go up because the resistance up is smaller than...
Yeah, but not all of the current. You're thinking we can try and use the formula for the resistance.
Yeah.
I don't think that would work only because of this stupid little battery thingy here. If this wasn't here, we could do that.
Is that a battery or something else?
It's a battery, but he doesn't actually say it's a battery, does he?
Yeah. Where to find it?
But in the last part, you define the EMF. So, Let's have a look at the last part now. Okay. Let's think. V equals I or 3 minus 5. Alright. Let me just, to help you out here, let me just draw the piece at the bottom. So what you have here, your battery, and then resistor here, 5, and then here, 3, and then it comes out. Okay. Now, what is the voltage in this one here? Again, V equals IR, so what is it? It'll be I1 times 5, but we know what I1 is, so can you tell me what it is, please?
Like 92 or 2.86.
What is it?
2.86. 0.83.
Yeah, that's fine. I was thinking point one, two times
3.
Oh, yeah, sorry.
Yeah, did you get it? What was it?
3.86.
2.96. Are you sure?
I read.
Someone
Yeah.
has the answer.
5 multiplied, no, 5 multiplied by 0.592.
Yeah,
2.86.
What is the answer, Steve?
It's not that. Well, I'm not there yet. Let's just check. What did we get for I1
0.592.
and I2? Yeah, so they're right. What is wrong with this? Let me think. Just be quiet. Eight. Please. Just give me a moment. Now please, dudes, please, it's the last part of the question. Yes. Alright, I'm just going to do it here. So, you have, but I'm not sure what formula he's using here. Please. I don't know if this is. I'll tell you what he wrote down, but I'm trying to figure out what formula he used. 3I2 minus 5I1. So 3I2, that's the voltage here. That's the voltage here. Oh. You know what? I'm not going to try and figure it out his way because I don't understand what way he's doing it. Let's just do it how we were going to do it. Okay, sorry. So what did you say, Brandon? The voltage here is 2.96, and then what's it in this one?
6.03.
It should be
6.03.
6.03. Okay. Now, look here. This is what I was thinking, and it's not what he does. So I don't know. If I get the right answer, I'd be very happy. But it's completely different to what he's doing. This is my logic. The voltage in this wire is 2.96. The voltage in this is 3.03. Yes? 6.03. But the voltage, you get some voltage from this. Yeah? So, do we know the voltage of what comes out? Or what goes in? No. Can you subtract these two, please? What do you get when you subtract these?
3.07.
Yeah, that's the answer. The voltage here needs to... Remember I said about the voltage here and here being the same? Sorry, I had a... It's so completely different to what he does here. Okay? I don't know. We know the voltage here. We know the voltage here. And remember that the voltage needs to be the same between the two. Yeah? So that means if I just subtract these, I get how much this is to be.
Can we
Yeah?
calculate the total voltage by using the total resistance?
I have the total voltage actually, because the voltage here must be the same as the voltage here. And hey, if I have two wires that are parallel and they join together, does the voltage increase, decrease, or stay the same?
Stay the same.
Stays the same. So what do you think the voltage is that comes out?
9.25.
No,
What? 3 point.
no.
2.96.
2.96. Why 2.96? What's the voltage in this wire?
2.96.
So what must it be here? And when they come together, it's 2.96. What happens to the current when they come together?
Decreases.
The current adds when they come together. Yeah.
But how come the voltage is the same as? Isn't the resistance smaller? So no, sorry.
Why is the voltage the same?
This is the current. The current is different from each other.
Oh yes, the current's different from each other. Yeah. Hey. Hey. I want you. Can somebody please tell me what is the voltage here? What did we say it was? 3.07. But does anybody see anything that's maybe wrong, or not wrong, but interesting or confusing?
Why is it one
Wait,
side
what is it?
like the other one? Like in the diagram. No,
Yeah,
Usually-
that indicates the positive and the negative.
but usually it's just a line, big line, small line.
Yeah, I don't know why they did it here. Anyways, the black one.
So
Yeah.
that two resistance has the same voltage, and use 6.03 minus the 2.96.
Yeah,
We get the EMF.
that's right, yeah. This here's the EMF. And what are you saying? Continue.
I don't know.
So EMF is the battery.
Yeah, this here, I'm saying that this here plus 6.03 should equal 2.96.
So
It's the other way around.
It's the other way around.
It's minus.
Yeah.
That's because if you look at the battery, Forgot the question? Look.
Stop is
Yeah, the battery's the other way around. You see, here's positive, and then what's this end here?
whoa, maybe. So the current.
I think this battery, is the wrong way around. Well, not that's the wrong way around, but what happens when you put a battery the wrong way around? No, the current still goes through it. The voltage is negative. What's the battery doing? Recharging.
Oh, yeah. You flip back.
Yeah, if you want to recharge a battery, you just turn it around. So the voltage, instead of being positive, becomes negative. So instead of giving you voltage, what does it do? Takes it away. So this voltage is 6.03, but we need it to be 2.96. So this actually eats up some of the voltage. Yes? So I guess maybe it's not really a battery. Maybe it's like
A charge.
a capacitor or something. Or
Yes, that's what I said. I did.
did you say capacitor, Artie?
I was thinking about it, but like it looks like a capacitor, but they said no, the EMF is written above it. So every time I tried to say it, they would be like EMF is written above it.
It is a battery sign, but Bilal is right. Normally I do batteries are normally done like this, you know?
Yes.
Anyways, I think this is an ugly question, the last part of it. Part A, B and C was nice, but part D was ugly. And the problem is part D is worth how many marks?
10.
10, which is actually...
Half of the.
We need to find the examiner.
I don't like it. Alright, next question now.